Hello there, and welcome to the Sleepy Science Channel. I'm so glad you found your way here tonight. Maybe it's been a long day, or maybe you're someone who likes to drift to sleep with quiet wonder, letting thoughts of distant worlds replace the noise of daily life. There's nothing you need to do now but rest. Let your mind grow still, your breathing slow, and your body light. Because tonight, we're not just closing our eyes, we're traveling among the stars themselves. We'll drift through the soft beginnings of creation, where clouds of gas and dust slowly became the first sources of light. We'll follow their lives, their glowing hearts, their tempests of energy, their quiet endings, and the endless cycle that gives birth to new worlds. Each fact tonight is a gentle story, a piece of the cosmos told in calm, simple words. A rhythm meant not to wake your curiosity, but to cradle it, to let it breathe and fade and rest beside you. And if these sleepy journeys bring you peace, consider liking this video and subscribing. It helps other dreamers find their way here too. Now, take a slow breath in and let it go. Feel the day drift softly away. Above you, the sky stretches wide, a canvas scattered with a billion suns, each one glowing, breathing, and whispering through the dark. Close your eyes, and let's begin. Fact 1. Before the first spark, long before the stars, before even a single flicker of light, the universe rested in silence. There were no suns, no warmth, only an endless ocean of darkness filled with invisible particles, floating and waiting. Hydrogen and helium, the simplest of atoms, drifted together like dust in a deep cosmic stillness. The universe had expanded from its fiery birth, but now it had cooled, a soft, dim hush after the storm. There was balance, but also potential, a promise written into the laws of nature themselves. Every grain of gas was like a seed, waiting for gravity's call. It was a calm without color, a slumber before creation. And in that sleep, the first dream of light began to form. Fact 2. The cosmic dark ages. After the first light of the Big Bang faded, the universe entered a long, tranquil night. This was the cosmic dark ages, a time when space was filled with nothing but invisible clouds, too cool to shine, too warm to rest. No stars, no galaxies, only the soft rhythm of expansion. Hydrogen atoms swirled gently, colliding and drifting apart again in the silence. Tiny ripples of gravity began to gather these clouds, slowly, patiently. Over millions of years, those ripples deepened into valleys of attraction, places where matter began to fall inward. Imagine it, a vast, soundless sea, where darkness was not empty, but heavy with waiting. And deep within that quiet, the seeds of the first stars began to take shape. Fact 3. Gravity's whisper. Gravity is the universe's oldest voice, soft, patient, and constant. Even in the darkness, it was speaking, pulling together the wandering atoms, calling them home. Wherever enough gas gathered, pressure began to rise, and with it came warmth, a faint glow hidden inside cold clouds. These invisible knots of gas grew heavier, tighter, warmer still. They spun slowly, gathering momentum, drawing in more and more of their surroundings. Each cloud was a cradle, its center a secret ember forming in silence. The universe was still dark, but inside these hidden nurseries, the first sparks of starlight were being prepared, and soon the cosmos would awaken, one gentle fire at a time. Fact 4. The first flicker. After hundreds of millions of years of silence, the darkness began to change. In the densest corners of the early universe, gravity's slow embrace grew strong enough to ignite a miracle. Hydrogen atoms, pressed close by their own weight, began to fuse, releasing light for the very first time. These were the first stars, enormous, blue-white giants burning fiercely against the night. They were short-lived, but their brilliance pierced the cosmic veil, scattering the shadows that had lasted so long. The universe was no longer silent. It had learned to glow. From that faint flicker, a new era began, the age of starlight, spreading softly across the vast dark sea. Fact 5. Nests of creation. Every star begins in a hidden cradle, a place where matter gathers like breath, drawn in before a sigh. These cradles, called molecular clouds, are vast, cold regions made of gas and dust. They drift through galaxies like ghostly veils, lit faintly by starlight filtering through their edges. Inside them, turbulence stirs. Waves of gas colliding, folding, and weaving into denser knots. Gravity then takes over, pulling those knots inward until they collapse under their own weight. From this quiet fall, a star begins to form. Invisible at first, wrapped in a cocoon of dust. To the universe, these clouds are nurseries. To us, they are reminders that even darkness can give birth to light. Each glow that follows is a whisper from a place that once slept in silence. Fact 6. A nursery of dust and dreams. Deep within those molecular clouds, the story becomes intimate. Tiny particles of carbon, silicon, and ice gather, swirling together in the thick, shadowed air. The temperature is only a few dozen degrees above absolute zero, calm, cold, and still. Yet in this near-frozen silence, something magical stirs. As gravity pulls inward, the pressure grows, and the center of the cloud begins to warm. In time, this warmth becomes a pulse, a heartbeat of creation. The dust glows faintly, like embers beneath a blanket of night. Each of these nurseries is a womb of possibility, where stars and planets are quietly imagined into being. And from one such place, long ago, our own sun began its first breath. Fact 7. The balance of pressure. At the heart of every forming star, a quiet struggle unfolds. Gravity pulls inward, trying to crush the gas and dust into a smaller and smaller space. But as the gas is squeezed, it grows hot, and that heat begins to push back. This gentle equilibrium between collapse and expansion is the foundation of starlight itself. It is a cosmic breath, a rhythm between two opposites, gravity's embrace and heat's resistance. Too little pressure, and the star would fall in on itself. Too much, and it would drift apart before ever igniting. When balance is finally found, the heart of the star hums in silence, holding perfect harmony. This delicate truce is how stars are born, not in explosions, but in quiet agreement. Fact 8. Ignition. And then, in that hidden heart, the universe changes forever. Temperatures climb to millions of degrees. Hydrogen atoms, once content to drift apart, now collide so violently that they fuse, joining into helium and releasing energy beyond imagining. This is fusion, the most peaceful of fires, yet the one that lights the cosmos. It begins softly, a spark too faint to see through the clouds surrounding it. But soon the glow strengthens, pushing away the darkness, spreading light into the dust. The protostar becomes a true star, a new sun, shining for the very first time. No sound accompanies it, only the silent birth of radiance. The night will never be the same again. Fact 9. The star's first breath. As the fusion settles into rhythm, the young star exhales for the first time. Winds of charged particles sweep outward, clearing away the cloud that once sheltered it. The surrounding dust drifts aside, revealing a newborn sun, brilliant and free. The light it gives is steady, warm, and eternal compared to its turbulent youth. It is the same light that will later illuminate planets, guide life, and mark the passage of time. Every twinkle in our sky is a reminder of this first breath, a moment when the universe learned to shine. And beyond this single star, countless others begin to awaken, one gentle flame after another. Fact 10. A new sun rises. When the dust clears, the young star stands revealed, a sphere of golden fire suspended in the dark. Its glow spills outward in every direction, soft and endless, touching the farthest edges of its birth cloud. The gas that once hid it now shimmers, painted in color by the light of its maker. Every new star is a sunrise for the universe. Their combined radiance turned darkness into dawn, transforming the once silent cosmos into a living sea of light. Each one burns not in rage, but in rhythm, a pulse of warmth that will last for millions, even billions, of years. From these newborn suns, the story of everything else begins. Planets, moons, oceans, and us. Fact 11. The core of fire. At the center of every star lies its beating heart, the core, where fusion burns with tireless grace. Here, gravity's embrace and heat's resistance hold steady, forging the elements of life one atom at a time. Temperatures soar beyond 15 million degrees, yet everything moves in silence, as if the fire itself were meditating. Hydrogen becomes helium, and with each fusion, a photon is born, a particle of light beginning a journey that will last thousands of years before it escapes to the surface. The core is small compared to the whole star, yet it is the only place where true creation happens. Within that invisible heart, the universe's story is written in light. Fact 12. The radiant path. From the star's core, light begins a slow and winding pilgrimage outward. Each photon drifts only a short distance before colliding with another atom, scattering in a random new direction. What would take a few seconds in empty space instead takes thousands, sometimes millions, of years. The star's interior is like a labyrinth of glowing fog, where light must wander patiently to find its way out. By the time it reaches the surface, it is changed, softened, and become the gentle starlight we see from Earth. That glow we wish upon, that faint shimmer in the night sky, it began long ago, in the deepest heart of fire, and above the core, another layer begins to stir. Fact 13. The convective dance. Above the radiant zone, the star's interior begins to move like a living sea. Here, great currents of plasma rise and fall in slow, endless cycles, hot gas drifting upward, cooling, then sinking once more. This is convection, the heartbeat of a star's surface, a gentle churning that keeps its light alive. Each motion is vast beyond imagination, cells of boiling plasma larger than continents, yet all in perfect rhythm. From afar, the surface seems calm and constant, but up close, it ripples with quiet motion, shimmering like candlelight. It is the dance of energy itself, gravity, heat, and motion weaving together in an eternal flow. A star breathes this way, and through that breath, the universe glows. Fact 14. The surface of light. We call it the photosphere, the visible skin of a star, the place where light finally escapes into space. It is neither solid nor still, but a thin veil of glowing gas only a few hundred kilometers deep. Here, the temperature drops compared to the blazing core, yet it still burns at thousands of degrees, radiating warmth and brilliance. Sunspots form here, dark, cooler patches shaped by magnetic fields, fleeting and ever-shifting. They remind us that even in brightness, there are patterns of rest and motion. Each patch, each ripple, is a signature of a living, breathing sun. From this luminous boundary, the light that began in silence finally journeys outward to planets, moons, and distant eyes watching the night. Fact 15. The corona's crown. Above the surface lies a mystery, a halo of gas far hotter than the layers below. This is the corona, a glowing crown that stretches millions of kilometers into space. It shimmers faintly, visible only during a solar eclipse when the body of the star is hidden and its halo shines free. No one fully knows why the corona is so hot, millions of degrees, far beyond expectation. But its beauty is undeniable. A soft, white flame rippling through the vacuum, shaped by invisible magnetic threads. The corona is a reminder that even stars have secrets, mysteries that dance at the edge of their light. And just beyond that halo, the colors of the stars begin to whisper their meaning. Fact 16. The language of color. Every star tells its temperature through its hue. Cooler stars glow with the warmth of embers, deep orange or red, like the fading light of evening. Hotter stars blaze in white and blue, their energy so fierce that it spills across the spectrum. Each color, each tone, is a note in the music of the cosmos. When we look up, we see not just brightness, but temperature, age, and energy made visible. The soft gold of our sun, the sapphire burn of Rigel, the ruby glow of Betelgeuse, each reveals a different heartbeat. And though they shine in silence, together they paint the night sky in gentle gradients of time, a celestial watercolor of warmth and distance. Fact 17. The pulse of brightness. Stars may seem constant, but many live in slow, rhythmic motion. Their light swells and fades, like a sleeping creature breathing in and out. Some pulsate because of the balance within, expanding when they grow hot, contracting as they cool. Others flicker because unseen companions pass before them, dimming their shine for a moment. These pulses can last hours or days or centuries, tiny cosmic heartbeats that echo through space. Astronomers study these rhythms to learn a star's size, its distance, and even its age. But beyond the science, there's a quiet poetry in it. The idea that every star, no matter how distant, has its own slow, patient rhythm, a lullaby written in light for anyone who stops to listen. Fact 18. The spectrum's secret. When a star's light passes through a prism, it breaks apart, not into chaos, but into order. Lines appear in the rainbow, dark or bright, each one marking an element within the star's body. Hydrogen, helium, carbon, iron, all leave their fingerprints on the light they create. This is how we know what stars are made of, even when they are trillions of kilometers away. Each spectrum is a story, a signature written by heat, by pressure, by time. Through these spectral lines, we read the biography of the cosmos itself. Every photon carries a whisper from its birthplace, and together, those whispers become a song of the universe. Fact 19. The magnetic weave. Inside every star, rivers of charged gas swirl and churn. These motions twist magnetic fields into loops and arcs, weaving invisible threads through the plasma. The result is a restless pattern, a magnetic dance that shapes everything from solar flares to sunspots. Sometimes, these tangled lines snap and reconnect, releasing bursts of energy that ripple far into space. At other times, they hold steady, sculpting the corona and guiding the star's radiant wind. Though we cannot see the fields themselves, Their traces shimmer in every flare and flicker. A star's magnetism is like a heartbeat within its glow, unseen but always present. It reminds us that even serenity is born from motion. Fact 20. The music of the sun. Every star sings, though not in sound we can hear. Waves of pressure move through their glowing bodies, rising and falling like the tide. These oscillations make a star tremble gently, its surface rippling in silent rhythm. Astronomers record these vibrations through subtle shifts in brightness, a science called helioseismology. From them, we learn about the layers hidden deep within, the rhythm of fusion, and the star's internal heartbeat. The sun, too, hums with these quiet tones, thousands of overlapping notes playing through its fiery shell. It is a song that began billions of years ago, one that will continue long after we are gone. A steady lullaby, written in light and plasma, for all who sleep beneath its warmth. Fact 21. A rainbow of suns. Not all stars are alike. They come in a spectrum of colors and temperatures, from the cool, red M dwarfs to the brilliant blue O giants. Astronomers arrange them in a simple but elegant sequence, O, B, A, F, G, K, M, a ladder of color that tells the story of energy, mass, and lifespan. The hottest stars burn bright and fade quickly. The cooler ones glow softly for trillions of years. Our sun sits near the middle, a calm, golden G-type star, balanced between youth and age. Together, they create a rainbow across the galaxy, a quiet symphony of light, from fierce blue to gentle crimson. Each one a spark, each one a heartbeat, each one a dream. Fact 22. Giants among us. Some stars live with a kind of slow, vast grace. They are the red and blue giants, swollen spheres of gas that have expanded far beyond their original size. A red giant can be hundreds of times larger than our sun. Its outer layers stretch thin and cool, glowing like an ember in twilight. A blue giant, by contrast, burns with blistering intensity, its light a sharp, radiant flame against the night. Though they seem eternal, these giants are near the end of their lives, their cores running low on fuel. Yet they shine with quiet majesty, painting nebulae and seeding the cosmos with new elements. Each one is a monument to impermanence, beauty born of change. And from their fading light, the next generation of stars will rise. Fact 23. The dwarfs glow. If giants are fleeting fires, dwarfs are slow, patient coals. Red dwarfs, the smallest of true stars, burn their hydrogen so gently that they can live for trillions of years. Far longer than the universe has yet existed, they glow with a deep, calm red, casting little light but endless endurance. Most of the stars in our galaxy are dwarfs, unseen to the naked eye, but filling the heavens in number. Around many of them, planets quietly orbit, bathed in their dim warmth. Though small, they are the caretakers of cosmic time, steady, humble keepers of light. When all other stars have gone, the last remaining glow of the universe will belong to these tiny embers, a slow, peaceful sunset stretched across eternity. Fact 24. Binary bonds. Many stars are not alone. They are born in pairs, two suns orbiting one another in an endless waltz. Sometimes they circle close, sharing matter and heat. Other times they drift far apart, bound only by gravity's invisible thread. These binaries teach us that companionship is woven even into the cosmos. Their movements shape each other's lives, affecting brightness, temperature, and destiny. Some end in harmony, others in collision, merging to form a single new star. Through telescopes, we can watch their rhythm. one star eclipsing another, their light dipping and rising in soft pulses. Even among the stars, nothing exists alone. Fact 25. Triplets and families. Beyond pairs, some stars form entire families, groups of 3, 4, or more, bound by gravity's patient hand. They orbit a shared center, tracing elegant spirals through the dark. In these systems, one star might shine bright, while its smaller siblings drift in gentle loops, their combined gravity weaving a delicate balance. Imagine standing on a distant planet in such a system, watching multiple suns rise and set, painting the sky with overlapping colors. The light would never truly fade. Dusk would blend into dawn in a soft, perpetual glow. These star families remind us that the universe, vast as it is, often prefers company. Even in the quiet of space, connection endures. Fact 26. The variable stars. Some stars do not shine with steady grace. Their light changes, sometimes subtly, sometimes dramatically. These are the variable stars, whose brightness ebbs and flows with time. In some, the star's surface expands and contracts in a rhythmic pulse. In others, dust clouds or companions pass before them, dimming their glow. To ancient observers, these changes must have seemed like the stars themselves were alive, breathing, sighing, or blinking across the heavens. In truth, their variations reveal deep truths about temperature, size, and the forces inside. Each flicker is a heartbeat of the cosmos, slow, soft, and infinitely patient. To watch them is to witness a star, thinking, dreaming, changing, just as all things do. Fact 27. Cepheid beacons. Among the variable stars, some are special, reliable as clockwork, steady in their change. These are Cepheid variables, whose brightness rises and falls in precise cycles. The longer their period, the greater their true luminosity, a cosmic rule that lets astronomers measure the vastness of space itself. By studying their rhythm, we learned how far away galaxies truly are. Their gentle pulses became the yardsticks of the universe, guiding us through distances once thought unknowable. Each Cepheid is a beacon, a heartbeat flashing across millions of light years, whispering, "I am here, and beyond me there is more." Their light bridges the infinite, connecting one quiet world to another. Fact 28. Neutron remnants. When a massive star dies, it leaves behind a heart of unimaginable density, a neutron star. Its atoms crush together until protons and electrons merge, leaving only neutrons packed tightly as a solid sphere of silence. Just a teaspoon of this matter would weigh more than a mountain. These remnants spin rapidly, sometimes hundreds of times each second, sending beams of radiation that sweep through space like the ticking of a cosmic clock. Though no longer shining with fusion, they glow with magnetism and motion, the echo of a once great flame. A neutron star is the universe's memory of power, condensed light, preserved in gravity's embrace. Even in death, it keeps turning, whispering its rhythm into eternity. Fact 29. White dwarfs. Smaller stars, like our sun, end more quietly. When they have burned all their hydrogen and helium, their outer layers drift away into space, leaving behind a dense, glowing core, a white dwarf. It no longer fuses elements. Instead, it shines softly with the heat of what once was. These ancient embers cool slowly over billions of years, fading from white to blue to red, and finally to black. Each one is a monument to endurance, the stillness after a lifetime of radiance. They are what remains when a star has given all it can, a spark that refuses to go out completely. To look at a white dwarf is to glimpse a quiet afterglow, the last breath of a long and luminous life. Fact 30. Brown dwarfs. Not every star manages to ignite. Some gather gas and dust, but never reach the heat and pressure needed for fusion. These are brown dwarfs, half star, half planet, glowing faintly in deep infrared light. They are the gentle failures of creation, yet even they have their own beauty. In their cool atmospheres swirl clouds of methane and dust, glowing softly like distant coals. Though too dim to be seen without powerful instruments, they drift between the stars like wandering dreams. Brown dwarfs remind us that not all light burns brightly. Some hum quietly, softly, in the unseen warmth of the dark. Fact 31. The main sequence. Symphony. Most stars spend their lives in a long, stable phase known as the main sequence, a quiet middle age where hydrogen steadily fuses into helium at the core. For billions of years, this process continues in near-perfect balance, gravity pressing inward, radiation pushing outward. It is during this time that stars shine their brightest and most peacefully, each following its own tempo depending on its mass. Large, hot stars race through this phase in only a few million years. Smaller ones linger for trillions, unhurried and content. The main sequence is the great melody of the universe, a slow, sustained chord that fills the galaxy with steady light. Every star you see tonight is likely playing this same patient tune. Fact 32. The balance within inside. Every shining star is a constant conversation between pressure and gravity. Gravity tries to draw everything inward, while the heat of fusion pushes outward in reply. The two forces meet in stillness, forming a fragile equilibrium that can last for ages. This balance is not static. It breathes and shifts, like the gentle rise and fall of the sea. A little more fusion, and the star swells slightly. A little less, and it tightens again. But through it all, the light remains steady, the song unbroken. It's a quiet reminder that harmony doesn't mean stillness. It means motion in perfect agreement. A star lives by that lesson, glowing not through struggle, but through balance. Fact 33. The long calm of red dwarfs. Among all stars, the red dwarfs are the patient keepers of time. Small, cool, and faint, they sip their fuel so slowly that they will outlive the universe itself. While massive stars blaze and die in brilliant bursts, red dwarfs glow with a steady, gentle persistence. They have no hurry, no drama, just a calm, enduring pulse of warmth. If life survives far into the cosmic future, it will likely find shelter near these humble suns, basking in their deep crimson light. In their serenity lies a message. Not all greatness burns fast. Some shine softly and forever. Fact 34. The swift lives of giants. Massive stars are born in brilliance and live in haste. Their enormous size makes their cores burn with furious energy, consuming their hydrogen in just a few million years. While our sun will last billions of years, these titans flare and fade in the blink of cosmic time. Their light is bluer, hotter, more intense. Their radiance powerful enough to sculpt the gas clouds around them. They shine so fiercely that their outer layers tremble, shedding streams of matter into space. But even in their rush toward death, they are beautiful, bright, impermanent blossoms on the galactic tree. Their lives remind us that even fleeting things can burn with unimaginable grace, and when they die, they gift their brilliance back to the dark. Fact 35. The age of a star. A star carries its age not in wrinkles or lines, but in its light. The color, brightness, and temperature all shift gently as it grows older. Young stars shine white or blue, their fires hot and restless. Older stars mellow into gold or red, their energy softening like twilight. Astronomers read these changes the way one might read the rings of a tree, a quiet record of growth and passage. By studying the light alone, they can tell whether a star has just begun its journey or whether it's nearing its final breath. Every glimmer in the sky is a different moment in time. Some are newborn flames. Some are ancient echoes. Together, they form a tapestry of ages, the living calendar of the cosmos. Fact 36. The metal of time. Stars are not only light, they are factories of matter. Through fusion, they forge new elements: helium, carbon, oxygen, and beyond. As generations of stars are born and die, the universe grows richer in these heavy elements, known as metals, in astronomy's gentle shorthand. The first stars were pure hydrogen and helium, pristine and simple. But each wave of death added more: iron, nickel, gold, until the cosmos itself began to sparkle with diversity. The atoms in your blood, your bones, your breath, all of them were born in these ancient furnaces. So when we speak of starlight, we are also speaking of ourselves. We are the metals of time, the dust of stars made alive. Fact 37. Fusion's gentle ladder. As a star matures, its inner fire begins to shift. When the hydrogen in its core is spent, the fusion moves outward, first to a shell around the core, then to deeper elements as the pressure rises. Helium begins to fuse into carbon and oxygen, step by step, up the quiet ladder of creation. Each rung burns hotter and faster than the last, a steady rhythm of transformation. In this way, stars build the very elements that fill galaxies with color and life. For massive stars, the process continues: carbon to neon, neon to silicon, and finally to iron, where the cycle ends. It is a graceful ascent toward exhaustion, a slow, shimmering climb to the edge of what physics allows. Fact 38. The end of equilibrium. Eventually, the balance that sustained the star begins to crumble. Fusion slows, gravity wins ground, and the core contracts under its own immense weight. The outer layers respond by expanding, swelling outward like a breath drawn too deep. The star grows vast and luminous, its surface cooling even as its heart burns hotter than ever. In this fragile phase, it becomes unpredictable, shedding gas into space, pulsing with slow, rhythmic brightness. What was once steady now wavers, a quiet reminder that all things must change, even the stars. This is not an end filled with violence, but with surrender, a graceful yielding to time and gravity, a soft unraveling of light. Fact 39. The quiet swell of a red giant. When a star like our sun reaches old age, it becomes a red giant. Its body expands hundreds of times its former size, glowing deep crimson and filling its sky with warmth. The outer layers thin into soft gas, drifting away like a shimmering veil. Planets that once circled safely may now be consumed or pushed outward. The balance that defined the star's long life gives way to beauty tinged with farewell. Yet there is peace in this transformation. For even as it fades, the star spreads its essence across space, planting the seeds for new worlds and new suns to come. And beyond that soft glow waits the final silence, the death of light itself. Fact 40. The death of light. When fusion can go no further, a star begins its final descent into stillness. Its core, now heavy with iron or carbon, can no longer create the pressure needed to fight gravity. The light that once poured outward for billions of years begins to dim, like a breath slowly leaving the body. For smaller stars, the collapse is gentle, a contraction into a white dwarf that glows faintly, cooling over eons. For larger ones, the end comes swiftly and bright, their inner balance snapping in an instant. In either case, what follows is not truly death, but transformation, a return of energy and matter to the cosmic whole. The light may fade, but its story continues, written into everything it once touched. Fact 41. Planetary nebulae. When a medium-sized star like our Sun releases its final sigh, it sheds its outer layers into space. The gas expands outward, illuminated by the still hot core at its center. This glowing shell of color is called a planetary nebula. Though it has nothing to do with planets, the name endures like an echo of early astronomy. Each nebula is unique. Some form soft, circular halos. Others bloom into complex patterns, rippling with symmetry and grace. The gas glows in blues, greens, and pinks, the spectral fingerprints of oxygen, hydrogen, and nitrogen made radiant by the fading star within. It is a beautiful farewell, a last display of artistry before the darkness settles in. In these luminous clouds, the universe paints its own eulogies, soft reminders that endings too can be full of color. Fact 42. Supernova dreams. The most massive stars die not in quiet, but in brilliance. When their cores can no longer sustain fusion, they collapse in a heartbeat, and then rebound in a cataclysmic explosion, a supernova. For a brief time, that single star can outshine an entire galaxy, its light reaching across millions of years. In the chaos, elements heavier than iron are forged. Gold, silver, uranium, scattered like seeds into space. These are the gifts that will one day become planets, oceans, and living beings. What appears to be destruction is, in truth, creation on a grander scale. A supernova is the universe's way of breathing life into its own ashes, and from that brilliance, the densest hearts are born. Fact 43. Neutron stars' crushed hearts. When a massive star collapses after its supernova, the core left behind becomes unimaginably dense. Protons and electrons fuse into neutrons, forming a sphere barely 20 kilometers wide, yet heavier than our entire sun. This is a neutron star, a city-sized ember of collapsed matter spinning with silent fury. Its surface is smooth and hard as steel, its gravity so strong that light itself bends around it. Some spin hundreds of times each second, their magnetic fields 1,000 trillion times stronger than Earth's. They are the densest visible things in the universe, the frozen hearts of fallen suns. And though they are remnants of death, they shine faintly on, whispering the echo of the explosion that created them. Fact 44. Black hole births. If a star is even more massive, its collapse goes further still. Gravity overwhelms every resistance, crushing the core until even light cannot escape. A black hole is born, not an object, but a boundary, a region where space itself folds inward. Around it, time stretches, matter spirals in, light bends into unseen paths. What enters cannot return, yet the edges of this void often blaze with energy, as infalling gas heats to extremes before vanishing. Black holes are paradoxes made real, absolute darkness surrounded by brilliance. They are not the end of existence, but the edge of understanding, a reminder that even the universe keeps secrets it will not yet reveal. Fact 45. Pulsars, cosmic beacons. Some neutron stars become lighthouses of the cosmos. As they spin, beams of radiation sweep from their magnetic poles, flashing toward us in perfect rhythm. These are pulsars, the ticking clocks of the universe. Each pulse we see is a rotation, measured with incredible precision, so steady that they rival atomic clocks on Earth. Through these pulses, astronomers can map space, test gravity, and even detect the faint tremors of gravitational waves. Their light arrives across millions of years, yet still it keeps time perfectly. In their steady blinking, there is both silence and music, a heartbeat echoing through the dark, marking the rhythm of creation's end and renewal. Fact 46. Recycling the elements. When a star dies, it does not vanish, it gives back. The gas and dust expelled in its final moments drift through space, enriched with the heavy elements it forged in life. Iron, carbon, oxygen, all of them carried outward on soft cosmic winds. Over millions of years, these fragments mingle with interstellar clouds, blending with hydrogen and helium to form new molecular nurseries. From this recycled matter, new stars ignite, new planets condense, and new possibilities emerge. It is a cycle without end, destruction feeding creation, endings nourishing beginnings. Every nebula we see is a cradle built from the bones of ancient suns. The universe breathes through this rhythm, endlessly renewing its own light. Fact 47. The gold in your blood. Some of the atoms that make you, the iron in your blood, the calcium in your bones, the gold in your rings, were born in stars that died long before our sun existed. When massive stars explode, they forge elements heavier than iron, scattering them into the galactic sea. In even rarer moments, when two neutron stars collide, they unleash torrents of energy that create gold, platinum, and uranium in a single blazing instant. These atoms travel across time and space, drifting for billions of years before finding a home in a planet, a tree, a person. To hold a piece of gold is to hold the memory of a cataclysm older than Earth. To breathe is to draw in atoms that once burned inside distant suns. We are not merely observers of the cosmos, we are its continuation, its living dust. Fact 48. Star nurseries. Reborn. From the remnants of the dead, new clouds gather once more. Supernovae and stellar winds enrich vast regions of space, cooling into veils of gas and dust, the raw material for the next generation of stars. Gravity gathers it again, as it always has, folding light back into darkness and darkness into light. In these nebulae, past and future coexist, the ashes of old stars mingling with the seeds of new ones. The Orion Nebula, for instance, glows with this very balance, a vast, glowing womb where stars are born amid the echoes of the ones that came before. Nothing in the universe is ever truly gone. It only changes form, continuing the quiet conversation between death and creation. Fact 49. The eternal cycle. In the universe, nothing is wasted. Every atom, every photon, every fragment of stardust finds its way back into the endless cycle of transformation. Stars are born, shine, die, and give birth to more. A slow, unbroken rhythm that spans billions of years. The calcium in your bones, the oxygen in your lungs, the carbon that makes you warm, all once belonged to another time, another light. In this way, life itself is the continuation of stellar memory. We are the cosmos, reflecting on its own existence, breathing through borrowed matter. There is comfort in this infinite repetition. Nothing truly ends. Nothing truly fades. Everything returns, changed, yet whole. Fact 50. The memory of light. Every photon that leaves a star travels outward forever, carrying with it the story of its origin. When you look at the night sky, you are not seeing the present. You are seeing the past, preserved in light. The glow from Sirius left its star 8 years ago. From Betelgeuse, 600. From distant galaxies, millions or billions. Light remembers. It travels patiently, never aging, never slowing, whispering tales of ancient suns across the void. Some of that light will wander endlessly, never striking a world or eye to receive it. Yet still it shines, crossing eternity without complaint. The universe is full of this gentle persistence. Messages written in photons, still traveling, still remembering. Fact 51. A common star with a rare gift. At the center of our solar system burns a star both ordinary and extraordinary, the Sun. It is one of billions of similar G-type stars in our galaxy, neither the brightest nor the largest, yet it holds a rare distinction. It cradles life. Its warmth falls softly on our world, not too fierce, not too faint. A perfect balance that allows oceans to shimmer, air to move, and living things to grow. Every sunrise we witness is an echo of that ancient equilibrium, a daily memory of our star's steady grace. In its modesty lies its miracle, a common star, quietly sustaining an uncommon world. Fact 52. The sun's layers of life. Our sun is more than a glowing sphere. It is a structure of harmony, layer upon living layer. At its heart burns the core, where fusion hums and light is born. Above it lies the radiative zone, where that light drifts outward in a patient, random walk lasting thousands of years. Then comes the convective layer, where heat rises and falls like a tide, stirring the surface from below. The photosphere forms the sun's visible skin, golden and alive with motion. Above that floats the chromosphere, a thin blush of color, and beyond it, the shimmering corona that extends into space. Each layer has its own rhythm, its own way of breathing light. Together, they form a single, radiant being, a living engine that holds our world in warmth. Fact 53. Solar wind's gentle breath. From the sun's outer atmosphere flows a constant stream of particles, a soft exhalation known as the solar wind. Made of electrons and protons, it drifts outward through the solar system, touching every planet, every comet, every speck of dust in its reach. On Earth, this invisible breath shapes our magnetic field and paints the sky with auroras. It hums across the vastness, carrying whispers of the sun's heartbeat into the dark. Though born of immense power, it travels quietly, a reminder that even great forces can move with grace. In this ceaseless outflow, the sun's presence extends far beyond its light, an unseen warmth that connects every world beneath its glow. Fact 54. The sunspot's shadow. The sun's surface is not perfectly calm. At times, darker patches bloom across its face. Sunspots, cooler regions shaped by tangled magnetic fields. They appear where the sun's magnetism knots and twists, holding back the flow of heat from below. To the eye, they are small, but each could swallow Earth whole. They shift and vanish, reappearing in cycles that trace the sun's hidden moods. Around them, flares burst and ribbons of plasma twist like silk in slow motion. These shadows are not flaws, but features, signs that even the most constant light contains movement, texture, and depth. Within their darkness, the star renews itself, quietly preparing for the next burst of brightness. Fact 55. Solar flares. Quiet fury. At times, the sun's serenity erupts into brilliance. When magnetic fields twist too tightly, they suddenly release, bursting into space as solar flares. These eruptions unleash streams of charged particles, floods of X-rays, and waves of energy strong enough to ripple across entire planets. Yet from afar, A solar flare is a thing of beauty, a slow, graceful loop of fire curling above the sun's surface, arching and fading like silk caught in the wind. Its heat and light reach us across space, sometimes brushing Earth's magnetic field, painting auroras in polar skies. It is a reminder that even the calmest star can hold fierce beauty within. Power and peace coexist in the same light. Fact 56. The heartbeat of an 11-year cycle. The sun lives by a quiet rhythm, an 11-year pulse of rising and falling activity. At the height of its cycle, sunspots multiply, flares erupt, and solar winds grow wild. Then, as the years pass, the surface calms, the spots fade, and the magnetic fields untangle again. This repeating heartbeat has guided our sky for centuries, subtly shaping space weather and even Earth's climate. Ancient observers once recorded the sun's moods in careful patterns, watching the ebb and flow of its luminous pulse. Today, we listen with satellites instead of eyes, hearing the sun's breath through data and light. It reminds us that even a star follows cycles of rest and renewal, a cosmic rhythm of work and sleep, flame and silence. Fact 57. The light that sustains Earth. Every second, the sun releases more energy than humanity has used in all of history. Yet a tiny fraction of that warmth, less than 1/billionth, is enough to sustain all life on our planet. Its light travels for 8 minutes across space, arriving as the soft gold of morning and the gentle warmth of afternoon. That radiance drives the winds, feeds the oceans, grows the forests, and stirs the pulse of every living thing. Every heartbeat, every breath, is linked to the sunlight that falls through the air. It is the quiet miracle of existence that a distant star, burning alone in space, could nurture a world into bloom. And still, it shines, unceasing, unjudging, endlessly giving. Fact 58. A star that feeds life. Every leaf that reaches toward the sky, every wave that shimmers, every breath of air, all are whispers of the sun's touch. Its light warms the seas, awakens the soil, and gives color to the quiet bloom of life. Through photosynthesis, its energy becomes food and fuel, stored in the green of leaves and the hearts of trees. For billions of years, the sun has nourished Earth without fail, its warmth falling evenly on desert and ocean alike. It asks for nothing, gives to everything. Every creature that has ever lived has carried a trace of its radiance, a memory of sunlight turned to motion, warmth, and thought. To live is to be shaped by a star, to be sunlight, walking. Fact 59. Our day star's future. But even the most patient light must one day change. The sun, now about halfway through its life, will one day run low on hydrogen at its core. When that happens, it will swell into a red giant, its heat softening and spreading far beyond the orbits we know. Mercury and Venus will vanish within its growing glow, and Earth may become a barren ember, scorched by its parent's final bloom. Yet from that transformation, new beauty will rise. Gases drifting outward, forming a nebula of color that will shimmer long after the sun's light is gone. Its end will not be destruction, but return, a release of all it has given, its atoms joining the same dance that began the cosmos. Fact 60. The final ember. When the red giant's fire fades, the sun will leave behind a quiet remnant, a white dwarf, small as Earth, yet holding half its former mass. It will glow faintly, not from fusion, but from the memory of warmth, the echo of what once was. For billions of years, it will cool and dim, drifting slowly toward darkness. But even in that stillness, its influence will remain. its light having seeded life, its gravity still shaping the silent relics that circle it. One day, it will be no more than a cold gem in space, a quiet testament to the long, luminous dream of a single, ordinary star. Fact 61. The nearest stars. Beyond the Sun, the closest star to Earth is Proxima Centauri, a small, cool red dwarf only 4 light years away. Its light is faint, invisible to the naked eye, yet it burns steadily, a quiet ember in the dark. Around it, at least one planet circles within the region where liquid water might exist, whispering the faint possibility of life beneath another sun. Proxima belongs to the Alpha Centauri system, a trio of stars orbiting each other in slow, elegant harmony. Their closeness makes them our first neighbors in the vastness, distant yet almost familiar. When we gaze southward and imagine interstellar travel, this is often our destination, a nearby shore in an endless ocean of stars. Fact 62. Binary companions nearby. Just beyond Proxima lie its companions, Alpha Centauri A and Alpha Centauri B, 2 suns locked in a gentle gravitational waltz, orbiting each other every 80 years. From a planet between them, the sky would never darken, one sun setting as the other rose, bathing the world in perpetual twilight. Alpha Centauri. A shines like our own sun, golden and steady. B burns a little cooler, a little dimmer, like a soft amber flame. Together, they form the nearest true binary system, a living reminder that most stars are not solitary. Their light blends across space, their gravity entwined, their partnership as old as the galaxy itself. When we look toward them, we see what might be possible, a twin sunrise over an alien sea. Fact 63. The familiar constellations. From Earth, we group the stars into shapes and stories, constellations that have guided us for thousands of years. To the Greeks, they were myths carved into the heavens. To sailors, they were maps across the waves. The North Star, steady in its place, has long been a compass for travelers. Orion, a hunter, strides eternally through the winter sky. Yet these patterns are only illusions, stars that seem close together but are separated by vast distances. Still, we keep them as our own, reminders that even in infinite space, the human mind finds meaning, and the heart finds direction. Every constellation is a story told in light, a soft connection between our world and the endless beyond. Fact 64. The Pleiades misty cluster. High in the night sky, a small patch of blue light shimmers like dust on glass. This is the Pleiades, or the Seven Sisters, a cluster of young hot stars born together only about 100 million years ago. They are still wrapped in the faint remnants of the cloud that formed them, a misty reflection nebula that glows with soft, icy light. Cultures across time have woven stories from their glow. Sisters fleeing a hunter, birds taking flight, sparks from a celestial forge. To the eye, they seem close and delicate, but in truth they span many light years, bound loosely by gravity and kinship. The Pleiades remind us that even among the stars, family endures. A cluster of youth shining through the darkness, never truly alone. Fact 65. Globular clusters. Ancient glow. Far older and denser than the Pleiades are the globular clusters. Immense, spherical gatherings of stars orbiting the edges of galaxies. Each one holds hundreds of thousands, sometimes millions, of suns packed tightly together, glowing with the soft gold of age. These clusters are among the oldest structures in the universe, fossils of a time when galaxies were still forming. Their light is steady, their orbit slow and eternal, like lanterns circling the galactic core. From afar, they appear as hazy pearls, concentrated memories of the first generations of stars. To look upon a globular cluster is to peer backward in time, to see the faint shimmer of creation still suspended in space. Fact 66. The galactic plane. Our Milky Way stretches across the night like a pale river of light. What we see as a misty band is actually the view from within our galaxy's disk, the galactic plane, a vast spiral of stars, gas, and dust seen from the inside. Billions of suns drift along this plane, orbiting the galactic center in quiet procession. Dark lanes of interstellar dust weave between them, sculpting the soft patterns that lace the sky. To lie beneath that glow is to feel both small and infinite. A single being beneath a bridge of light so wide it encircles the world. It is the horizon of the cosmos itself, the path upon which every star quietly travels. Fact 67. Stellar streams. Across the galaxy, faint ribbons of stars weave through the dark, relics of ancient collisions. These stellar streams are the remains of small galaxies long ago drawn into the Milky Way's embrace. As gravity pulled them apart, their stars stretched into graceful trails that still orbit the galactic core, like threads of silver drifting through shadow. Each stream is a fossil in motion, tracing the quiet violence that shaped our home. The Sagittarius stream, one of the brightest, wraps around the Milky Way like a soft spiral of memory. In their motion lies a cosmic tenderness. Even when torn apart, these stars continue to dance together, bound not by origin, but by gravity's patient hand. Fact 68. The Milky Way's heart. At the center of our galaxy lies a crowded, glittering city of stars. The galactic bulge. Here, suns are packed thousands of times more densely than in our region of space, their light blending into a golden haze. Amid this dense radiance hides a quiet giant, Sagittarius A, a supermassive black hole with the mass of 4 million suns. It does not devour recklessly, but waits, turning slowly, shaping the motion of everything nearby. Around it, stars move in perfect arcs, their orbits tracing invisible geometry through the night. Though we cannot see its heart, we feel its influence everywhere, the steady center of our galaxy's spiral grace. It is the pulse at the core of the Milky Way's luminous body, silent, powerful, eternal. Fact 69. Our spiral. Home from afar, the Milky Way would appear as a vast, spinning spiral. Arms of stars curling gently from a glowing core. We live in one of these arms, the Orion Spur, a quiet neighborhood between grander spirals. Our sun circles the center once every 230 million years, moving with billions of other stars in a vast shared rhythm. Dust and gas trace the arms like brushstrokes, glowing softly in infrared light, forming new stars as they turn. From within, we see only fragments, a sky full of scattered sparks. Yet together, they form a masterpiece of motion. The Milky Way is both home and horizon, a luminous wheel turning endlessly in the dark. Fact 70. The edge of light. Far from the Milky Way's bright arms lies a vast, dim frontier, the galactic halo. Here, the number of stars dwindles, replaced by ancient clusters and faint streams of forgotten light. Dark matter fills the space beyond, unseen but essential, its gravity shaping everything within. The halo stretches like a ghostly shell, marking the boundary between our galaxy and intergalactic night. Few stars dwell there, but those that do are old, relics from the dawn of time, orbiting in patient solitude. If one could stand on a world at that distance and look inward, the Milky Way would hang in the sky like a glowing spiral shell, soft and immense, a galaxy breathing in darkness. Beyond it, other galaxies shimmer faintly, silent neighbors, each with their own sea of stars. Fact 71. The nature of fusion. Every star lives by the same quiet law. When atoms join, light is born. Deep within a star's core, hydrogen nuclei collide so fiercely that they merge into helium, releasing energy as pure radiance. This is fusion, the process that powers all starlight, all warmth, all motion in the cosmos. The transformation is subtle yet profound. A tiny fraction of mass converted directly into energy. Einstein's equation, E mc2, becomes a living truth inside each star. The light from that reaction pushes outward, holding gravity in check, a balance so perfect it can last for billions of years. Fusion is both creator and caretaker. It builds the universe one atom at a time and keeps the stars alive long enough for life to dream beneath their glow. Fact 72. Quantum tunnels and probabilities. At the heart of fusion lies a mystery. How can atoms, both positively charged, ever overcome their natural repulsion? The answer lives in the strange realm of quantum physics. Particles do not simply collide, they also tunnel, slipping through barriers that classical logic would forbid. Inside a star, this quantum tunneling allows fusion to occur at temperatures far lower than expected, a quiet trick of nature that makes every sunrise possible. It is a reminder that even the laws of physics contain grace, that the universe, in its smallest workings, leaves room for wonder. Fact 73. The photon's long journey. When a photon, a particle of light, is born in a star's core, it begins a journey that seems eternal. Before it ever escapes into space, it must weave through dense layers of plasma, colliding, scattering, and re-emerging countless times. Each step takes it only centimeters forward, then sends it off again in a new direction. A single photon may spend tens of thousands of years, sometimes more than 1,000,000, wandering through its parent star before finally breaking free into the open dark. Once it does, it travels unhindered, racing across space at light speed until it meets an eye, a leaf, or a grain of dust. Every beam of sunlight that touches your skin began this voyage eons ago, its warmth a memory of the star's patient heart. Fact 74. The speed of light's patience. Light is the swiftest traveler in the universe, 300,000 kilometers every second. Yet space is vast, and even such speed must bow to distance. It takes 8 minutes for sunlight to reach Earth, 4 years for light from Alpha Centauri, and over 2 million years for the glow of the Andromeda Galaxy to arrive. When we gaze at the stars, we see them not as they are, but as they were. Tiny lanterns showing us ancient moments frozen in their shine. In this way, the night sky is both map and memory, a living photograph of cosmic history written in light. Each twinkle above is an old voice still speaking, reminding us that nothing truly leaves the universe. It only travels onward at the speed of forever. Fact 75. Luminosity and distance. Not all stars shine with equal strength. Some burn bright and bold, others glow faintly, hidden behind veils of dust. Astronomers measure a star's true brightness, its luminosity, to understand both what it is and how far away it lies. By comparing the light we see with the light a star should emit, we can measure distance across incomprehensible space. This method, like reading whispers in the dark, lets us map galaxies, trace cosmic structures, and measure the scale of the universe itself. The dimmest light, when read with care, can tell the story of worlds we will never visit. Even faintness has meaning, and even distance has song. Fact 76. The color of stars. Every star glows in its own hue, shaped by its temperature and age. The hottest stars blaze blue-white, their energy fierce and concentrated. Cooler stars glow gold, orange, or red, radiating with a softer warmth. Between these extremes lies a rainbow of suns, each a different note in the symphony of light. When you look up and see the faint tint of starlight, a hint of sapphire or amber, you are seeing physics and poetry intertwined. Color reveals the story of a star's heart, its heat, its youth, its fading years. Even invisible light, beyond what our eyes can see, carries its own quiet colors in ultraviolet and infrared, painting a fuller picture for those who listen with instruments rather than sight. The universe is not just dark and bright, it is endlessly tinted, a living gradient across eternity. Fact 77. Spectral signatures. When starlight is spread into a spectrum, it becomes a barcode of creation. Lines appear, dark and bright, each marking the presence of an element within the star. Hydrogen, helium, sodium, oxygen. Each leaves a distinct fingerprint in the light, an unchanging rhythm written by atoms themselves. Through these spectral signatures, astronomers can tell what a star is made of, how fast it spins, even how quickly it moves toward or away from us. It is as though each star sings its own unique song, and by listening carefully, we can learn its melody and meaning. This discovery turned light into language, the silent poetry of physics translated into understanding. Fact 78. Reading starlight's secrets. When we study a star's light, we are not just seeing, we are decoding. A telescope's prism or detector can split a single beam into thousands of data points: color, intensity, vibration. From that, scientists learn the star's temperature, its distance, its chemical balance, and even the motion of planets orbiting around it. Every flicker carries information. A slight dimming might mean a world crossing its face. A subtle redshift might reveal a galaxy rushing away. Light becomes a universal language, a form of touch that can cross millions of light years without fading. To read starlight is to listen to time itself, to hear the quiet murmur of the cosmos speaking through color, pulse, and patience. Fact 79. Doppler's gentle shift. When a star moves towards or away from us, its light changes subtly in color, a quiet echo of motion. If it approaches, the waves of light compress, shifting slightly toward blue. If it drifts away, they stretch, sliding toward red. This is the Doppler effect, the same principle that makes a passing sound rise and fall in pitch. Through this gentle shift, astronomers can measure a star's movement, even if it lies billions of kilometers away. We can tell whether a galaxy spins, whether a planet tugs on its parent sun, or whether entire clusters drift through the cosmos. It is astonishing that movement itself leaves a trace in color, and that from a single beam of light, we can sense the direction of eternity. Fact 80. The expansion of space. Long ago, astronomers noticed something extraordinary. Nearly all galaxies show a redshift, their light stretched as if they are receding. The universe, it seemed, was not still but expanding, every cluster of stars moving away from every other. Space itself is stretching, carrying galaxies along like leaves drifting apart on a rising tide. This discovery changed everything. It revealed that the universe had a beginning, a moment when all was compressed into light and heat. And though expansion sounds like movement through space, it is space itself growing, gently widening with time. Even now, this expansion continues, quiet and steady. Every second, the cosmos grows larger, and the distances between stars whisper softly of time's long breath. Fact 81. The red light of distant galaxies. As the universe expands, the light from distant galaxies stretches with it. What once shone blue or white now glows in deep crimson or fades into invisible infrared. The farther away we look, the redder the light becomes. A time machine of color, showing us galaxies as they were billions of years ago. Some of this light began its journey when stars were first forming. Some comes from galaxies that no longer exist at all. Yet still it arrives, carrying the memory of their brightness across oceans of emptiness. In this reddened light lies the history of everything, a slow, gentle fading that tells us not of loss, but of distance, age, and wonder. Fact 82. The cosmic background glow. Everywhere you look in the universe, even between the stars and galaxies, there is a faint glow, a whisper of warmth that fills the sky. This is the cosmic microwave background, the afterglow of creation itself. It comes from a time when the universe was just 380,000 years old, when matter cooled enough for light to travel freely for the first time. That ancient light has been stretching ever since, cooling into invisible microwaves that now bathe all of space in a quiet, uniform haze. It is the oldest light we can see, a kind of cosmic lullaby, soft, steady, and everywhere at once. To detect it is to touch the edge of time. Fact 83. The echo of the Big Bang. Long before stars or galaxies existed, the universe was a sea of energy, hot, dense, and blinding. As it expanded, that fire thinned and cooled, and the echoes of its birth faded into the cosmic background we see today. Tiny variations in this ancient light, minute ripples in temperature, reveal the first seeds of structure, the places where matter would one day gather to form stars, clusters, and worlds. In those faint fluctuations, we see the blueprint of everything to come. Every galaxy, every beam of light, every life form owes its shape to those early ripples. The Big Bang was not an explosion in space, but the creation of space itself. A quiet beginning that continues still, expanding, evolving, breathing. Fact 84. The first light of the universe before. That moment of transparency, the cosmos was opaque, filled with glowing plasma where light could not travel freely. But when atoms first formed, photons were released into open space, beginning their endless voyage. That was the first dawn, not of a single star, but of light itself. In that instant, the universe became visible, and every beam since then has been a continuation of that first illumination. Even now, when we gaze through powerful telescopes, we glimpse the faint glow of that ancient morning, the first sunrise the universe ever saw. It is not just the light of creation, it is the memory of awakening itself. Fact 85. The birth of the first stars. After hundreds of millions of years of cooling and quiet, the universe stirred again. In vast clouds of hydrogen and helium, gravity began its slow work, drawing matter together until the first stars ignited. These were giants, enormous and hot, 100 times the mass of our sun. They burned fiercely, their blue-white light piercing the cosmic night. Their lives were brief but vital. In their cores, they forged the first heavy elements, carbon, oxygen, iron. And when they died, they spread these new materials into space, enriching the darkness for generations to come. These first stars were the universe's first artists, turning the raw simplicity of creation into color, chemistry, and possibility. Fact 86. Galactic dawn. From the gathering of those early stars, galaxies began to take shape. Delicate spirals and glowing clouds coalescing in the great void. Tiny clumps of matter merged under gravity's patient pull, forming islands of light amid the endless black. This was the galactic dawn, when the universe first became organized, structured, and bright. The earliest galaxies were small and chaotic, their light scattered by cosmic dust. But with time, they grew into majestic spirals and graceful ellipticals, each one a universe unto itself, home to billions of suns. Even now, their faint light still reaches us, a whisper from 13 billion years ago, telling of the moment when darkness first learned to shine. Fact 87. The reionization of the cosmos. When the first stars and galaxies ignited, their radiation swept through the surrounding gas, stripping electrons from atoms and turning the universe transparent once more. This event, called reionization, marked the end of the cosmic dark ages. The fog that once filled space thinned, and starlight could travel freely again. The universe became clear, vast, bright, and alive with energy. Every ray of light you see today, every photon that reaches your eyes, travels through the clarity born of that age. The reionization was not a violent storm, but a gradual unveiling, a quiet lifting of the cosmic veil. And when it passed, the universe was forever changed, open, radiant, and awake. Fact 88. The architecture of galaxies. Each galaxy is a masterpiece of gravity and time. Some are graceful, spirals, their arms curling like smoke around glowing hearts. Others are elliptical, vast ovals of ancient stars drifting in quiet harmony. Still others are irregular, cosmic sketches shaped by collisions and chance. At their centers, many hold black holes, millions or even billions of times more massive than the sun, surrounded by disks of swirling gas that blaze with energy. Within their arms, new stars continue to form, while the outskirts grow dim with age. Every galaxy is both a cradle and a grave, a place where matter is endlessly reborn. From afar, they appear serene. Up close, they are vibrant, dynamic, alive, each one a symphony of light, written in gravity's patient hand. Fact 89. The silent collisions. Though galaxies seem isolated, they are destined to meet. Over billions of years, gravity draws them together, their halos overlapping until they merge into one. When this happens, stars rarely collide. There is too much space between them. But their clouds of gas crash and compress, igniting new waves of starbirth. To us, such events would unfold in slow motion. Two spirals approaching, their shapes twisting into ribbons, their colors blending like ink and water. What might seem destructive is, in truth, deeply creative. In their silence, galaxies embrace and reshape each other, turning chaos into beauty, a cosmic waltz that gives rise to new stars, new worlds, and new beginnings. Fact 90. The dance of the local group. Our Milky Way is not alone in its journey through the universe. It belongs to a small cluster called the local group, about 50 galaxies bound together by gravity's quiet tether. Among them are Andromeda, our majestic neighbor, and dozens of smaller companions, faint, delicate spheres of ancient light. Over the next 4 billion years, the Milky Way and Andromeda will drift closer until they merge, forming a new grand galaxy, perhaps called Milkomeda. The stars will not clash, but weave together, their orbits finding new harmony in the aftermath. In this future union lies no tragedy, only transformation, a gentle continuation of the same story that began when the first galaxies met. Even across cosmic time, everything that drifts apart eventually finds its way back home. Fact 91. Dark matter's invisible hand. All across the universe, stars and galaxies move in ways that visible matter alone cannot explain. Something unseen holds them together. A vast web of invisible mass we call dark matter. It neither shines nor absorbs light, yet its gravity sculpts the shape of galaxies and clusters alike. We know it is there because of how galaxies spin, too fast for the amount of visible matter they contain. Dark matter forms halos around them, unseen scaffolds on which the visible universe hangs. Through it, we glimpse the skeleton of creation, a structure made not of light, but of gravity's quiet strength. It is a reminder that most of the universe is invisible, and that what we cannot see often holds everything in place. Fact 92. Dark energy's gentle push. If dark matter holds the universe together, dark energy drives it apart. This mysterious force fills all of space, pushing galaxies away from one another and accelerating the expansion of the cosmos. It does not act like gravity, nor like light, but as something subtler, a constant pressure woven into the fabric of existence. We discovered its presence by watching distant supernovae grow dimmer than expected, revealing that the universe's expansion is speeding up rather than slowing down. Even now, dark energy remains one of the great enigmas of science, unseen, unmeasured, yet undeniably real. It is the quiet hand on the universe's shoulder, guiding it outward, softly, into infinity. Fact 93. The shape of the universe. What is the form of everything? Is space flat, curved, or folded in ways beyond our imagining? Through careful observation of distant light and cosmic geometry, scientists have found that the universe is nearly flat. Its vast structure balanced between collapse and endless expansion. But on the grandest scale, its true shape may be more complex, perhaps looping back on itself like a sphere, or rippling outward like a wave that never ends. In this vastness, there is no center, no edge, only continuity. The universe curves gently, endlessly, like a dream with no horizon, where every path eventually becomes part of another. Fact 94. Gravitational waves, soft tremor. In the quiet of the universe, even gravity can sing. When massive bodies move, black holes merging, stars collapsing, they send out ripples that stretch and squeeze the very fabric of space. These are gravitational waves, faint vibrations moving at the speed of light, crossing the cosmos with ghost-like gentleness. For billions of years, they traveled unnoticed, until in 2015, humanity first heard their subtle hum. Detectors on Earth felt a tiny shiver, smaller than the width of an atom, as space itself quivered. It was the sound of two black holes colliding a billion years ago, their union echoing across time. Each wave that passes through us is a reminder that the universe is not silent. It hums softly, endlessly, with the memory of motion. Fact 95. The fabric of space-time. Einstein taught us that space and time are not separate things, but threads woven together into one grand fabric, space-time. Every mass, from a pebble to a star, bends this fabric, curving the paths of light and motion around it. We do not orbit the sun because it pulls us, but because the space around it curves, and our planet follows that curve like a leaf drifting in a circular stream. Even light, which knows no rest, follows these curves, bending gently near massive objects. When we gaze at galaxies whose shapes seem stretched and mirrored, we are seeing this bending made visible. Gravitational lensing, a window into the invisible geometry of the cosmos. Space is not empty. It is supple, dynamic, and alive with the contours of energy. Fact 96. The unity of matter and energy. Everything we see, from the smallest grain of dust to the brightest star, is energy given form. Einstein's quiet equation, E mc2, reveals that matter and energy are two faces of the same truth. When matter moves, it can become light. When light is trapped, it becomes matter. This unity means the cosmos is not made of separate parts, but of transformations. Endless exchanges between motion, heat, gravity, and time. Every star is energy turned solid, and every photon is a whisper of matter unbound. We too are part of that exchange. Temporary arrangements of light, breathing, and aware. Fact 97. The fate of the stars. Every star, no matter how vast or gentle, must one day fade. The bright blue giants will burn their fuel quickly, dying in explosions that scatter their light across space. The smaller, humbler stars, red dwarfs, will live far longer, glowing for trillions of years before finally cooling into darkness. In that far future, galaxies will no longer shine as they do today. Only faint embers will remain, white dwarfs cooling into black, neutron stars spinning down into silence. Yet even in their endings, stars will continue to give, their atoms drifting outward, waiting for new patterns, new possibilities. The night will grow quieter, but never empty. Even in the dark, the memory of light endures. Fact 98. The dimming of the universe. As time stretches on, galaxies drift farther apart. Their light grows redder, fainter, until one by one they slip beyond the reach of sight. Future observers, if any remain, will see only their own island galaxy, surrounded by endless black. The cosmic background radiation will cool to nothing, and the last glimmers of starlight will fade into invisibility. It will not be a sudden end, but a slow, graceful dimming, a long exhale after an age of brilliance. In that stillness, the universe will not die, but rest. Its energy spread thin, its heat spent, its beauty remembered only in the faint hum of existence. The great symphony will not end in silence, but in the softest note imaginable. Fact 99. The long night to come. In the distant future, when all stars have faded and black holes have evaporated into nothing, the universe will enter a time of deep, endless night. This era, the Dark Age, will last longer than all of history combined. There will be no warmth, no light, only drifting remnants, scattered atoms, and the quiet geometry of empty space. Yet even then, there will be a kind of peace. The universe will have completed its cycle, from energy to form, from light to rest. And in that infinite calm, perhaps something new may stir, a whisper of rebirth hidden within the stillness, waiting, once again, to become light. Fact 100. The endless dream of the cosmos. Though the universe may one day fall quiet, it will never truly end. Energy may thin, stars may fade, but the patterns of existence will remain, subtle, infinite, eternal. In every empty space lies the potential for new creation, a spark waiting for the right moment to awaken once more. Some theories suggest the cosmos may breathe again, collapsing inward, then blooming outward in another great expansion, a cycle of death and rebirth without beginning or end. Others say it will stretch forever, a dream that never fully closes its eyes. Whichever path it follows, the universe will continue its gentle rhythm, always changing, always remembering, an endless dream where light and time softly trade places. And we, small and brief, are part of that dream, the cosmos thinking quietly to itself. And as our journey comes to a gentle close, I hope you found a little calm among the stars tonight. We've drifted through the birth of suns, the music of galaxies, and the quiet promise that even in darkness, the universe still hums with light. If you enjoyed this quiet voyage through sleepy facts, remember to like the video, subscribe, and share in the comments what corner of the cosmos you'd love to dream about next. When you're ready to keep drifting, you can let the next story carry you deeper to another night of wonder and another 1,000 tiny suns waiting in the dark. Until then, close your eyes, breathe softly, and let the universe hold you. Sweet dreams, and see you among the stars.